Well, what we're going to do tonight is we're going to talk about the hollowing system that I manufacture. And the reason we're talking about that tonight is that Eldon was using the one that belongs to the club that's back there that I'm not going to demonstrate tonight because it doesn't fit this lathe. It fits the jet lathes back there. So want all the club members to know how to set it up and how to use it. This will be fairly short. First of all, when you hollow an item, it is a good idea to drill out the middle part of it, because even if you're turning the lathe at a high speed, really the wood here in the middle isn't turning very fast. And while this hollowing system will cut right to the middle of a piece, it's a slow process because it just isn't going, the wood isn't going fast. So drill out that center part however you wish to do that, and that'll save you a lot of time. What we usually do is that we use a Colt Forstner bit, Colt MaxiCut Forstner bit, which cuts so easily that you can actually put it on the end of the boring bar and just push it into the piece by hand. However, they quit making Colt Forstner bits about 3 or 4 years ago, and some people that were smart enough bought them up, and I wasn't one of those people that was smart enough, so I don't have a pile of these. We found a couple of brands that we've been playing with that work fairly well. I think this is a Roman. Yeah, this is a Roman carbide. This is made in China. I think, Tyler, you told me about these. They're pretty decent. They still take more pressure than the Colt MaxiCuts. And so when Joe and I put this on the end of a boring bar, we both have to push on the boring bar to push it in. But we can still do it by hand. I think I can modify this. In fact, I have another one. No, I don't have it here. I have another one at home that I did remove some of these side tips because I can see that basically you're pushing this sideways through the wood. It takes quite a bit of force. So I modified that, but I haven't had a chance to try it out and see if that helped much. Now we're going to use this one tonight in the way that most of us would do this. And by the way, this tailstock sits here with nothing in here, and I never do that in my studio. I always have something in the tapers, because if you leave them open like this, dust and dirt gets in there, and then the next thing you know, these babies don't hold in there very well. So you can avoid having that problem if you just always keep something, one of the tapers, in your tailstock, into the taper.
You hear that?
Now I get somebody in trouble already.
Somebody likes to go around and disassemble everything before we leave at the end of the day.
So I'm just going to bore out a little bit of this one. And the other thing that I didn't do here that I should have is when I turn this lathe on right away, I can see that this is on high speed. And there are reasons to have a lathe on high speed. If you're going to turn small diameter things, absolutely high speed. But in my studio or shop, you know the difference between a studio and a shop, I've told everybody this before, it's a zero, but it's the last zero in the price. So it's an important zero. Studio or shop, I always keep all of my lathes on low speed range because we have no need to turn things really fast. And if we did put one of those, well, a vessel even that diameter, and put it on a high speed range and turn it up to the top of speed, that thing would probably explode. And that's not a fun thing to have happen. So anyway, I didn't bother to change this tonight. We're not going to be here that long. We're not going to be doing that much. And that's about as slow as that baby will go right there, which is, for me, is pretty quick. So here you just take this and going through. You crank it in there like that. And we've gotten rid of the inside now. That's enough. Boy, this is rusted too. So that's basically all we have to do with that. We've got our center turned out. It's out of our way. We're not going to use this. Yep.
take out is just that much, or do you do a small one and then a big one and then a little bit bigger?
The size that we use is slightly larger than the boring bar. So this is a 1-inch boring bar. We would use a 1 1/16 or a 1 1/8 inch Forstner bit. Now that does not leave you really enough room for chips to come around through the bar. That's not a problem, because when you're pushing that in there, you need to pull it back out frequently and clear those chips. Otherwise, you're going to have this little situation where you have your Forstner bit trapped in there, and the only way you can get it out is take this off a lathe and cut it apart and free your bit up. So you want to be sure and do that frequently. This we don't need.
Sounds like voice of experience on that last one.
Absolutely. Yeah, well, that's how we learn things, of course. Best way to learn them all. The hollowing system that we use basically consists of 3 parts. And we have an extra part here tonight. But you have the boring bar, which is this steel part right here. This is not a part of it. This is an option. What's on the end of here right now is an option also. But the boring bar is one part. The trap is another part that goes in here. So the neat thing about this is, since it goes in your banjo, if you have a short bed lathe, you put your banjo clear back out here, and you've just basically extended the ability of your lathe a whole bunch. We don't have a boring bar long enough for that here tonight. These shaft collars that are on here and on here are there so that each time you set this up, it should be correct. And actually, this I have two 3520s. This comes off of one of the 3520s, so it should be set up for this lathe, hopefully. So this is one piece. The second, and that supports the back end of the bar. We call it the trap, and it arrests the torque on the bar. The next piece here is, we call it the nose support. This part right here.
When you set that up, do you set it up that your tool, the cutting head of your tool, is on center? You set it up slightly above center, slightly below center?
Yes. I'm sorry, Tim. I couldn't resist. It needs to be on center or slightly above. If it's below, it won't work. We use the Monroe Hollower 2, which, where are the? Shelf over here?
To your right, up there.
Oh, I see them. Okay. Green ought to work fine. So basically, what you have is a cutter that's like a little cup here like this. And there's a guard over that cutter. And then down underneath here, of course, is the support for this. And that is fastened down through there. So you have, if you're cutting and well, let me do this on an now you can see if you have something that's round like this, if you're a little bit high, you're going to be bumping into it up here, and you're not going to be able to get into the cut. And if you're down here a little bit low, you're going to be bumping into this part right here, and it's going to keep you out of the cut. So where you are up and down is critical. And if you're right on center or slightly above, it should work just fine. If you get much beyond that, then you won't. The cutter just won't cut. Nothing will be happening. And that's a reason why that you must set your boring bar up parallel to the ways of the lathe. Because obviously, if your boring bar is on a slant, as you go in here, you're going to go down below center. Or if it's like this, you're going to go up above center. So you need to have that bar be parallel. The way you do that, I'll show you that. So, what's close? So basically, you can't turn this bar now You see, it can't turn over because the trap has arrested the torque. So all the downforce on this cutter back here is going to be absorbed by these bars right here. Now, in order to set this up, the way to do that is you can use a level. But if I put this level on here and level that bar, and the lathe is not level, then they're not parallel. So what I need to do is take my level, put it down here, and see where that bubble is, and then go up here and make the adjustment. And actually, work this. It needs to go up. I don't know where that's going to leave me there, but now we're level, or we're matching this with that. So we know that these two are parallel, and it's not going to cut up or down as it goes in. And I think we're a little bit high, but we're just doing a demo tonight anyway. And let's see. Adjustable open end wrench. Could somebody grab one real quick? I had one back there earlier. Nope, don't see one.
There was one sitting up here somewhere earlier tonight. Where did I see that?
There was on,
Unless it was out here.
That is definitely high.
That's probably what it was. It was sitting, if you leave anything out for
Can you
very
still
long,
buy,
Daryl will pick it
can
up.
you still buy that cutter that you use on the end?
Yeah, we still sell those. Yes,
Crescent wrench, he's calling it.
thank you. Adjustable open end wrench. Hey, you bear in mind that I was an industrial education major. You know, it was on the test. What's the name of this wrench? Monkey wrench? No, that's an F. No, adjustable open end wrench. A got an A. And I can see right now. I don't know why, but this thing should be set up, and I'm not going to go through.
Banjo's probably different height than yours like this.
Yeah, it's because everything's too high. So I'm just going to drop this down, and we're not going to go very far anyway, so it doesn't really matter.
Steve, how small of an opening because I'm looking at your vase, right? How small of an opening do you have to have?
This part of the assembly right here is 5/8 of an inch, and your Monroe will probably go through a 5/8 hole, pretty close to it, maybe 3/4.
Okay, so that's the
So,
smallest it
yeah.
could be.
Obviously, when you get up to the bar, you're going to have to be bigger. But we do make an extension that's 5/8 of an inch that's about 10 inches long.
Okay.
But
And
as
then-
long as you're using that extension, you have to have the extension on here. You can't do this, have the bar on here and have that extension coming out here 10 inches and
Vibrate.
expect it to work. That won't work.
And
If
then
you use
how
the
much
extension,
room
that's
do you
gonna be-
need for, obviously, as you're deflecting, you have to, it's not straight, it's at an angle, right?
Oh,
So-
you can adjust this any way you want.
Right, but I'm just
Monroe,
thinking if you only have 3/4, how,
how you go around and get on the inside.
Right.
This comes with one extension. More extensions are available.
so you can curve them?
So you can put these little pieces in here. You can make this thing come clear back around here
Okay.
if you want to. They're $45 a piece. But if you get this cutter very far off center, then you're going to have enough torque on here that these bars are going to start spreading a little bit, and you're going to get a vibration. For that, we make a heavy-duty version with heavy bars, and you can run 4, 5, 6 inches off center here, and you still arrest your torque just fine. But I sell one of those every 2 or 3 years. It's really rare that anybody needs to do that. All of those vessels we do, we never put that extension in here. Well, I shouldn't say never. If we're doing a really large vessel, we would get probably to, I got to get back up here so I can get on the video, I guess. If we were right inside this part of the vessel right here on a very large vessel that was maybe 12 inches in diameter or more, then we would have to use an extension to get right up under this part right in here. Other than that, we never use them. So we've got the three basic parts, which is the trap, the bar, and the nose support. The nose support has a this pin in it, which is called a guide pin. And there are two positions where the guide pin can go. While this part of the nose support arrests your down forces, this arrests the horizontal oscillations. If you've done any hollowing, you'll know that when you're inside there, your tool, whatever you're using, tends to want to go back and forth. And on almost any piece of wood you're going to get your hands on, because the density of wood is generally not the same all the way around. Obviously, where it's more dense, it's going to cut less, and where it's a little bit easier, it's going to cut a little deeper, so that gives you that oscillation. So if you just keep the bar against that guide pin, you won't have any of that horizontal oscillation. That's what it's there for. It is not there so that you can put a whole bunch of force on this. Like any other cutting tool, if you find yourself having to put a lot of force on this cutting tool, something is wrong. It's not sharp, or you've got the wrong set, or maybe you've got this situation here where you're trying to bruise your way through the wood instead of cut. So it should cut really easily. And by the way, this bar, if we wax this, we take some paraffin. I think I got some here. So if I take paraffin and put paraffin in here, and I put paraffin on this bar, and then we go around here like this, you should be able to take one finger and move this bar anywhere you want. Even on the big bars that are 1.25 inches in diameter and 78 inches long and weigh 50 pounds. So once you get it waxed, steel on steel, it moves very easily. So my point there is that some systems have rollers here. And supposedly that's so you can move the bar back and forth more easily. You actually will not be able to tell the difference there, but where you will tell the difference is when you've got the roller there and you start running this in, you'll find that it tries to steer your bar for you in a place that you didn't really want it to go. So you have to fight those rollers all the time. I'm about right there. So now we've got this sticking out just maybe a little bit too far. So we're going to talk about options. One option we've already got assembled here, I didn't bother to disassemble, is the laser. I think the club has a laser. And the way that works, let's see, if I turn this on here, and if you can see that dot on the other side, if I set this, of course I'm on the other side of it, and I can't really show you because over here, but I would set, how's that?
Camera's picking it up.
Well, yeah, but I was going to say the way I set that is I would put my thumb out here like that, and look where the laser dot is in relation to the cutter here. And if that's about 1/4 inch, and 1/4 inch is what I want my thickness to be, then I've got it set right. Now, how do I tell? Now, bear in mind, you got to do this backwards because I'm going to be on this side instead of that side. But if I have that dot, so it just is making a little bit of a line, a horizontal line on the outside of that vessel, about like that, I know that I am that 1/4 inch distance away from there. When I'm up here like this, I know that I'm too close. If I go like that, I should start looking for wood flying up in the air and find that I now have two pieces of the vessel. So that's what the laser does. That's one option. We use that all the time, and it's very accurate. There's a little bit of a problem with parallax here as you go in there, and depending on your shape, as you change the angle of this bar, obviously that's going to change that distance. But it's real easy to get used to that and compensate for it, especially after you go through a few vessels. So yeah, it's a great incentive.
Was
I'm
the
gonna pull
pun
this back.
intended go through?
Yeah. Yeah, like we said, you learn a lot by making mistakes. But if you don't try. Now, the next option that we also have, the club has, is a center steady. And I think I left enough room to get this in there.
There's a question from online about why you don't have a safety
Because I went to get the safety pin and then I got distracted and I didn't get one. I didn't bring one. I usually have one. I don't know why there isn't one in this box. But I'm glad somebody brought that up. I was going to try to gloss over that and not say anything. But you should never, never, ever use this boring bar without the safety pin in here. If you are concentrating down there on your vessel and you get this bar down inside there and it catches and it goes down and around that way, this end is going to go up and around this way. That's if it pulls through. If it pulls through the trap and it's no longer in the trap, which is about the only way you can ever get a catch, is to have it come out of the trap. And so it's no longer controlled. And that'll come up and around and it's just right about where your head is and it'll probably kill you. So the safety pin is extremely important. There is a way that we use it without the safety pin. I probably shouldn't say it, but we do. If you set this bar up, I'm just going to explain. If I set this bar up so that when I get my cutter all the way back here to the chuck, I'm still in the trap here, I know that I can't pull it through. So we do that way, but I'd rather say don't ever do it without the safety pin because it's a deadly error if you happen to pull it through. Who was that was smart enough to bring that up? Was it Joe?
Joe Duncan.
Oh, Joe Duncan. Okay, well, he knows. He's got a system.
You want to see it?
Thank you. For the sake of all of us, there's the safety pin. There's no way that'll come through here now. So we're going to tighten the, I'm just going to take the center stage down here and snug it just a little bit. And the way we generally set, the way I set these up, now this is running really quite true, amazingly true, but I would bring this wheel up so it's just touching that. In other words, if I turn this, now it's spinning that wheel. And then I bring the other wheel up so it's just touching. Now both of those wheels, I didn't put any pressure on those wheels, I just brought them up to touch. This one, however, and I tightened them. This one I'm going to bring down. Now I'm going to put down force. I'm going to pull this one down and tighten it. Now I'm going to spin this and I'm going to put my finger on here to drag, put a little drag on that wheel. And if that wheel stops at any point, I would go to that point and reset it until it doesn't stop anywhere. So now I know that this piece is trapped within those three wheels and is not going to vibrate. We make our own wheels because we couldn't find any that would satisfy us. Most of the center steadies that you'll find out on the market have rollerblade wheels on them. And if you take your thumbnail and push it into the edge of that rollerblade, you'll find that you can dent it with your thumbnail, which means that as you turn on this piece can actually move in those wheels a little bit and you can get vibration. That's why we make our own wheels.
When you're doing one of your vessels that's already got the shape, outside shape to it, I'm assuming, before you hollow it.
Yeah.
How do you run those wheels, like just the inside or just the outside of the wheel?
The wheels have to run. I'm glad you brought that question up, Tim. The wheels, by the way, we always start out with green wood. Those are always turned green. Maybe I shouldn't say always, because right now I'm turning one on a dry piece of wood. But it's a rare wood that I've had for years and years and years, and I know it's dry. It's difficult to turn dry wood, to hollow dry wood. Green wood is so much easier, but the point I was going to make is, first of all, your wheels need to be, like on this vessel, if we were going to put the wheels on this vessel as it's shaped right now, the wheels would need to be at the high point here, the widest diameter, right centered on there, or on this rim. If you run it down here or in here or in here, those wheels are going to try to run uphill. And what will happen is your center steady will start doing this, because it'll try to run uphill until this overpowers it, pulls it back, and that'll just keep going like that.
So you
So-
see a lot of those green.
Yeah, so,
Don't worry about them warping or whatever then after.
oh
you
yeah,
convert 'em?
we lose some. But the ones, you see the ones that are where you can't see the wood anymore? That's where they go. If they split or crack, then they become a different kind of a vessel. So, the other point I wanted to make about green wood is that you need to put a wheel track on that one before you hollow it. And that needs to be at least 1/8 of an inch proud of where you're going to end up, especially on light colored woods like maple or birch or anything like that. If you don't do that, the pressure of these wheels rolling in there all the time will actually moosh the lignin, that is the glue that glues all the little straws together in the wood here. It'll actually moosh that down a little bit and redistribute it. And when this piece dries, you will have a band there that is a different color than the rest of the wood. And that can be 1/8 of an inch deep. You try to turn it out, you're going to go through the vessel. So be sure you put that wheel track on there. Once you're done hollowing, you take the wheel track off and then hang the vessel up to dry. By the way, if you want more detail about this whole process, I have a video online on YouTube. I think it's like an hour and 50 minutes or something like that, that shows the whole process from the very beginning with a piece of fresh cut wood to a finished vessel. In a whole lot of detail. I have to say it's kind of a poor video because it was never intended to be to end up on YouTube. It was just one that a guy took one time when I was doing a demo up in Wisconsin, and he gave me a copy of it, and I thought that's better than nothing, so I put it on YouTube.
Steve,
So-
you said that there is a special way of orienting the steady rest because it's designed for the laser or because it's angled, the wheels.
we build these, they're 7 degrees, they're tilted 7 degrees. I shouldn't say tilted, they're turned 7 degrees. So instead of being, this spoke, instead of it being right in the middle, straight up and down, it's slightly off to the side. And that gives you clearance through here for your laser. The alternative, this is high enough, you can go up here and go over the top of all this if you want. But the higher up you get this, the tiniest little vibration you get up here is going to seem to be multiplied down here. So the closer you can keep this, the tighter you can keep it, the more accurate you're going to be.
So essentially, at least for your system, make sure that the outside of the wheels is away from the tailstock.
Yeah.
Like you
Yeah,
never,
if
you,
you-
never
if you-
design them where the wheels are on the back.
Like Eldon had it set up the other way around, and he had that done for a specific reason, for a clearance reason, which is fine. Then you're going to have to deal with this situation over here, and the way you can do that with this system is you rely on this offset over here. This is another offset that helps with that. So if we had this post were right exactly in the middle here, when we got down inside there, you would find yourself having a lot of problems with interference. So that's all. These
So essentially, in 99% of cases, that's the way to set it up.
yeah, yeah. And this, I tell people, we didn't sit down and design this system. We evolved it. It evolved out of other people's designs, primarily Frank Soudal, the Canadian, who I was very, very fortunate to get to study with back in about 1997 and for a few years thereafter. But my system was based on what I learned about his. But like most things that we do is I looked at that one and I said, I can see ways that I can improve on that system. So that's where we came up with this.
your wood so that the wheels don't leave any mark?
No, and that won't, as far as I'm concerned, what I just said about marks, that's the way you do it. You leave a wheel track. Tape won't do it. I don't know, but there's not a tape in the world that I know of that would survive the pressure of these wheels. So it may on the soft rollerblade wheels, I don't know. I wouldn't try it. But I think you'd end up with a gooey mess if it took you very long at all. Because tape is fine when you put it on and leave it there, but start rubbing on it and rub on it for a while and see what happens to it. So basically when you use this, start her up here. When you use this, this hand, your left hand, basically just holds this bar against there, and you don't have to get in there and push against the bar. You just kind of like keep it there. A finger or two will do it, and then you come in here like this, and this hand does the steering. And is Joe out there? Joe is probably laughing at me because I think I'm a little bit low now. Yeah. So that's it.
So
And
is that you do most of your hollowing at the speed you're at right there?
no, I actually, if I weren't doing a demo for this one, probably about like the
What speed are you at right there? Like,
right speed. Well, I don't know. It said 276, then it said 212, and it said 6 something. 601. But don't get hung up on RPMs. I think everybody here has heard me say this before. This little device on this lathe here that tells you the RPMs that this lathe is turning at is there to sell you the lathe. It has no practical purpose unless you want to sit down and calculate the diameter of the piece and the number of surface feet per minute that you want, and then go accordingly. And as you start turning, that changes constantly. So the speed that is right for this diameter is way wrong for out here, because the wood's moving a whole hell of a lot faster out here than it is there. So RPMs doesn't mean crap. What is important is surface feet per minute. Now, if they put a readout on there that says number of surface feet per minute, that'd be fantastic.
you're turning at what feels right to you with the wood.
Yeah, you'll learn what works with these bars, with this cutter, with the Monroe Hollower 2. The wood goes down into this cup and then squirts back up through. Now, it has to make about a 270 degree turn. There's a limit to how much wood you can put through there that's making a 270 degree turn. I mean, you'll know it immediately when you exceed that speed, or you have this open too far and you just won't cut anymore. It'll be plugged up. And by the way, a lot of people that don't understand this type of tool, which is I call them a guarded ring tool. That's not technically correct because ring tools, the wood goes through the bottom. In this case, it's a guarded cup tool, maybe I should say, because it has to squirt back up the top. But anybody who's familiar with those is very familiar with the fact that there's a limit, and it's a hard limit. As soon as you get there, that's it. You can buy a lot of these tools cheap sometimes because some people don't understand that. I have customers all the time call me up and say, hey, this thing won't cut. I said, what speed do you turn at? Oh, about 1,200 RPM. Yeah, you're 2-3 times the speed you should be. Turn it clear down. Why don't you start at about 100 or 200 and keep turning the speed up until it doesn't cut anymore, and you will have found the most efficient speed. But bear in mind, as the diameter changes, that speed changes. But you saw how quickly, when I turned the speed up to the right speed, you saw how quickly we got a lot of wood out of there. I don't want to make a mess here. I make a lot more in a hurry. So that's basically the system. As the club owns one here, it fits those lathes back there. Feel free to use it. If you have any questions about it, call me. If I can answer the phone, I will answer the phone. If I'm in a rehearsal or somewhere or in a meeting or something, I turn my ringer off. You don't have to call back again some other time, or I'll call you back. But technical support is available whenever I can answer the phone.
When I was messing with it back there the other day, I can see now, I think, because the vessel that I was working on was pear-shaped, if you will, as the bar was in quite a ways, the boring bar, the laser bar was bumping against the top exactly.
You had it backwards.
Yes.
Yeah.
Yes.
Yeah, so you actually had it over here.
So
Yeah.
I
So
did-
one thing you can do about that.
Okay, that's where I was going to
think Joe
ask
tightened
next.
that one. Joe, you still on there? I have to tell a story about Joe. The first time Joe came over to work in my shop, make a shop. So he put the center steady up and he tightened that thing down. And then Joe wasn't there, I don't know. I went over to take it down and I couldn't get the bolt loose. And I finally had to, 2 hands in the cheater bar to get the bolt loose. And actually sprung the threads on the nut and bolt. So I got on Joe a little bit next time he came around. He said, yeah, well, he said, I grew up on a farm working on combines, and that's what you had to do. Well, here, actually, that center steady, just a light snugging, that center steady is not going anywhere. Same thing here. This is not going anywhere either. You don't have to crank them down to the point where you're going to wreck a grade 5 bolt and nut. So, any other questions?
I had a comment.
Yeah.
If you had a situation like Eldon did where you have the center steady going the other way, since you got an offset on the laser, you could offset it out this way and run.
You could.
Run it off.
Yeah, this could go over here. But it would have to come back across.
Oh, no, that wouldn't work.
So actually the best thing for what he was doing is just to do this. Now you're above the whole mess. And so you get, see the little bit of wiggle we get here gets magnified as we get up there. So, and these,
Is that a manufacturing error?
no, you can snug this down to where it's just maybe a hair loose. So the way I set these up, and there's also a video on that. You bring this bar over here, you tighten this nut down to the point where you just can't move this, and back it off just to the point where you can move it, and then you go over to this end, and you do the same thing over there, and then you come back and do it here again, and you come back over there and do it there again. And once you've done it twice on each end, you'll have this thing set so that there's not going to be any noticeable movement in that. And you can still move the bar. We actually, when this one was manufactured, I don't think we milled this bottom one, but we actually now, because this is welded, that'll warp this, and then we have to straighten it. And in order to get it back to flat, what we do now is put this on the milling machine and make a skinny cut across here so that's absolutely straight. And these bars, as they come, this is mill run, they're pretty damn straight for the most part. Once in a while you'll find one that's not, but mostly they're straight, so that's not a problem. Anything else?
Is the guard on the cutter, is that just for chip deflection, or what are
The guard on the cutter keeps you from having, if you tried using this without the guard, you'd go right through that side in no time at all. It'll self-feed. If you open this cutter clear up, this thing will self-feed in there, and you only have to do that once or twice, and you.
So that'll only allow you to go so deep.
Yeah, it controls the depth of cut.
And then come back out and go again, and come back out and go again.
And I'm glad you brought that up, because I also want to mention that on green wood, you can open this up quite a ways. And on dry wood like this, you want to close it way down. And you'll get roughly equivalent wood removal amounts. So in green wood, you can get chips just like you would get off of a gouge. Nice long chips will come streaming out of there if they don't get broken up in here, which is possible sometimes.
And the tool tip that we have at the club, I think, is just the scraper, It's that regular little.
You don't have the Monroe hollow?
No.
Yeah.
So is that one, because I think you tighten it with a screw, if I remember correctly.
Yeah,
So
you
so
can
is there a depth that you're trying to have it, past, clearing past the bar? or-
Actually,
or it doesn't matter?
As long as you're using this, as long as you're using the guide pin here, you should be able to control that pretty well. Personally, I like to keep it close and short so that you don't overcut. If you happen to go in there too far and get a good bite, you may not like the result.
The reason why I was asking is I took it out when I was using it to sharpen it, and I wasn't sure for putting it back in if
Put it
there's.
in whatever way it works.
Okay.
You can clamp it in there any left, right, up, down, upside down, whatever you want. It'll go in there. Anything else? Anybody? Okay, 8:15, 10 after 8.
Well, thank you.